Hello guys, welcome back to our channel. Today we are going to discuss about what is a T flip-flop and how to make the Verilog code for the T flip-flop. As we know that the JK flip-flop, which is nothing but it overcomes the drawback of the SR flip-flop. In the SR flip-flop, what is the drawback? We have, if we apply the both inputs as a 1-1, we getting the undesirable state. That means the Q and the Q bar values will be same, but it will be never possible in the real. So the JK flip-flop overcomes the SR flip-flop by making this toggle condition. That means if we apply the both inputs as a logic 1, then the output will be toggle each other. That means complement to each other. Now this T flip-flop is nothing but it always complement, it produces a complement output. Okay. So now to create the toggling function, we will use this case of the JK flip-flop. So to use this flip-flop, we have to change a small connection. That means we will connect the J and the K as a single input. That means here you can observe that this is a clock and this one is the J. I will write as a tree or J, K, Q and the Q bar. Okay, here I am considering input as a T and I will short this J and the K inputs. Okay, now we will write the truth table for this T flip-flop. So obviously we have T clock, T and the Q, right? If it is a clock is 0, irrespective of the T input, the output will be saved. It will save the previous state. If I apply the clock as 1 and T as 0, this means if I apply T is equal to 0, that means if T equal to 0, J equal to 0, K equal to 0, right? Because a single input will be applied to the both of the inputs. So if both of the inputs are 0 0, then what is the state? Memory. So I am writing as memory. And if I apply clock as 1 and the T as 1, that means now if T equal to 1, then J equal to 1 and the K equal to 1, right? If J equal to K equal to 1, what is the output condition? Toggle. That means the output will be Q bar. What is the previous output? If the previous output 0, then now the output will be 1. If the previous output is 1, then now output will be 0. In this way the T flip-flop will be work. In this way we can derive the T flip-flop from the JK flip-flop. Now we will start making the Verilog code for this T flip-flop. Okay guys, now start making the Verilog code for the T flip-flop. So for that I am creating the module with the name called T flip. Okay, and now we require inputs, right? Here we am taking the input reset, clock and T, and we require one output register Q. Now I am using the always block. Always at the rate pause edge clock. Pause edge means it is an executive device, right? Flip flop is. So we are considering the pause edge of the clock. Only when the pause edge of the clock is received, then only the device will start working. Okay, now if reset equal to 1, then what will happen? I think Q is all Q will be 0, and else begin if t equal to 1, then only we have to perform the toggling condition. So q equal to less than or equal to, here we are writing the q less than equal to because it has to store the previous state, so that's why we are using this type of syntax. If we don't care about the previous condition, then we have to simply write the q equal to in this, else q is equal to q, and ending the else case. And here we have to forget to write else begin. Okay, here I'm writing end module. Okay, Now I will start writing the module test bench, module TB. Here register is nothing but the register reset. Register is representing the inputs of the module. Register, reset, lock, and T, and outputs are Q. Now I am extracting the inputs from the design code T flip 1. What are the inputs and the outputs? Reset, clock, T, and the Q. I'm closing this. I am start giving the test bench. Before that, I will give the clock, and before that, I will write the dump file command. Dump file dot vcd numpads 1 clock equal to 1. Forever, for every 10 seconds, clock will be changed to clock. Alright, and I'm ending this. Okay, now I will starting the initial begin. Now I will give the initial, I will give reset equal to 1. So in this case, irrespective of the input, the output will be 0, and I will give some time delay as 10. Okay, now I will give reset equal to 0, t equal to 1, now t equal to 0, and reset is also equal to 0. And again I will give reset equal to 0 and t equal to 0. Okay, this is the attachment which will sufficient for our module to verify and module. Okay, now let's run this code whether it is working good or not. There is some syntax error in the test bench and design code SV.18. Let's see. Here we have to give another n. Here I'm saving the T flip-flop, saving this file, and I will run this. Yes, here we got the output. Here you can observe that initially reset is 1, so irrespective of the output, the Q is 0. Here you can observe that T is 1 but Q is 0. And when the clock is I and T equal to 0, the Q is still 0. And here I will again add this one condition. You can better understanding this. Yeah, you can see here t equal to 1 and the clock is y, then the previous condition is 0, so now q is toggling. In this way t flip-flop will be work. If you like this video, please like the video, and if you have any questions, please mention in the comment section. Thank you for watching this video. Stay tuned for the next video.